Hello students, welcome to the video. In this session, let us see some other examples of exponential distribution. See this example, the mileage which an owner can get with a certain kind of radial tire is a random variable. Here, the random variable is radial tire, okay, having an exponential distribution with the mean 4000 km. Find P of x greater than 2000. Second, find P of x less than or equal to 3000. In words, find the probabilities of one of the tires will last at least 2000 and at most 3000. Okay, so use this word here, at least, here at most, or at most. For every problem, we should define properly what is x and corresponding probability density function. Probability density function. Here, what is x here? X is the mileage of radial tire. Mileage of radial tire. Okay. So with the mean, here the exponential distribution, the mean is 1 by lambda equal to 4000. So lambda equal to 1 by 4000. Okay. So clearly x follows exponential distribution with the parameter lambda. So what is the probability density function? F of x equal to lambda into e power minus lambda x. What is x? X greater than or equal to 0. Here lambda value equal to 1 by 4000 e power minus 1 by 4000 into x. Okay. So let us see the first question. P of x greater than 2000. The radial tire will meet at least 2000 km. Already we know that probability of any random variable greater than constant is e power minus lambda into the constant. Here the constant is 2000. Okay, so e power minus lambda value 1 by 4000 into 2000 equal to e power minus 1 by 2. E power minus 1 by 2. So what is the answer? Use your calculator. You may get the answer 0 0.6065. 0.6065. Next, very simple, probability of x less than or equal to 3000. So we may get the value here 0 to 3000 and f of x dx. Instead, I am going to do, already know that probability of x greater than constant. So let us make, in order to this, using total probability 1 minus p of x, here less than or equal to, so greater than. If it is less than, we may use here greater than or equal to. So greater than 3000. Now what is p of x greater than 3000? That is equal to e power minus lambda value here 4000 into 3000. So answer e power minus 3 by 4. So e power minus 3 by 4 value 0.4724. So what is the answer here? 1 minus 0.4724. So answer, final answer is 0.5276. So here the required data only p of x less than 2000, p of x less than or equal to 3000. Okay. Suppose p of x less than or equal to 5000 kilometer or less than 5000 kilometer. What we should do? 1 minus p of x greater than or equal to 5000. So using the same condition, we may obtain this value. We may try at your home. Okay. Next, the daily consumption of milk in excess of 2000 gallons in is exponentially distributed with mean 3000 gallons. The city has a daily stock of 35,000 gallons. What is the probability that of 2 days selected at random, the stock is insufficient for both days? Okay, so already told you, for every problem we should define x, that is random variable x, and corresponding probability density function. Here, what is the random variable? Daily consumption of milk. Not daily consumption of milk is a random variable. Excess only. Excess 2000 gallons. Excess of 2000 gallons is exponential distributed with mean 3000 gallons. So 1 by lambda equal to 3000. So lambda equal to 1 by 3000. Okay, so what is the random variable? X is the daily consumption. X is the daily consumption. Y is the excess. Excess means more than 20,000. More than 20,000. That is what the excess. So just to subtract daily consumption from the daily consumption, we subtract 20,000, remaining only excess. That is exponentially distributed with mean lambda equal to 1 by 3000. So what is the probability density function? F of y, not f of x. F of x is daily consumption. Random variable is excess only. So excess only y. F of y equal to lambda into e power minus lambda y. So y greater than or equal to 0. That is f of y equal to 1 by 3000 e power minus 1 by 3000 into y. Okay, now let us see the problem. What is the probability that 2 days selected? We are going to select 2 days, so first day and second day randomly. The stock is insufficient. So the stock is insufficient. When the stock is insufficient, daily consumption is 20,000. Okay, the city has requirement what? 35,000. That is excess is what? 15,000. So the insufficient stock, when it will happen? More than 35,000. More than 35,000. That means based on X, daily consumption needs greater than 35,000. Excess Y greater than 15,000. 15,000. Let us see. See, the stock is insufficient. The stock is insufficient. The stock is insufficient. That is daily consumption greater than 35,000. Okay, so subtract y. Y equal to x minus daily x is 20,000. So 35,000 minus 20,000 equal to 15,000. So what is the question now? Probability of x greater than 35,000 equal to probability of y greater than 15,000. So e power minus lambda y. So e power minus, lambda 15,000. So e power minus 1 by 3000 into 15,000. What is the answer? E power minus 5. So e power minus 5 we should keep as it is. So for these 2 days, first day and second day, per day e power minus 5, second day e power minus 5. Here already told you exponential distribution, first event, second event does not affect. So both are independent. So P of A intersection B or P of A union B equal to P of A into P of B. So first day e power minus 5, second day e power minus 5. What is the answer? E power minus 10. So answer is 0.00045. That is the answer. Okay. Thank you.